According to quantum theory enthusiasts, the Mandela Effect presents evidence that the multiverse does exist. This belief is based on the idea that within each universe, parallel realities and alternate versions of events are present and mixing with the timeline. The objective here is to explore what we know about our universe, as well as other popular hypothetical possibilities. Could quantum mechanics be responsible for the Mandela Effect? One of the biggest differences between the classical world and the quantum world is the notion of determinism. In the classical world of physics, including mechanics, gravitation, and electromagnetism, the equations that govern the laws of nature are all completely deterministic. If you can give details about all particles in the universe at any given moment in time, including their mass, charge, position, and momentum at that particular time, then the equations that govern physics can tell you where they were and where they'll be at any moment in the past or future. But in the quantum universe, this simply isn't the case. No matter how accurately you measure certain properties of the universe, there's a fundamental uncertainty that prevents you from knowing those properties at the same time. There are many other examples of uncertainty in quantum physics, but many of those uncertain measurements don't just have two possible outcomes, but a continuous spectrum of possibilities. It's only by measuring the universe or causing an interaction of another quantum function that we discover which possible outcome describes our reality. An experiment called the double slit experiment has shown that the mere act of measuring an action of quantum particles affects the outcome. The experiment goes like this.
Single particles, such as photons, pass one at a time through a screen containing two slits. If either path is monitored, a photon seemingly passes through one slit or the other, and no interference pattern will be seen. This is where the weird begins. If neither photon is observed, it will still pass through both slits before interfering with itself, acting like a wave, changing the pattern. Is it the act of not observing that causes the quantum wave function to collapse from a particle to a wave? Or is it that each and every possible outcome that can occur actually does occur, and not just only in our universe? Is it possible that there are an infinite number of parallel universes out there, and that all possible outcomes occur infinitely many times? It takes the act of measurement to know which one occurred in ours. These might seem like radically different possibilities, but they're all consistent interpretations of quantum mechanics.
At this point in time, the only differences between the universe they describe are a philosophical one. From a physical point of view, they all predict the same exact results for any experiment we know how to perform at present. However, if there are an infinite number of parallel universes out there, and not simply in a mathematical sense, but in a physical real one, there needs to be a place for all of them to live. We need enough universe to hold all of these possibilities and to allow there to be somewhere within wherever possible outcomes can be realized. The only way this could work is if the universe was born infinite in size or infinitely a long time ago, and specifically the notion of eternal inflation, which has to correctly describe our pre-Big Bang universe. The universe needs to be born infinite because the number of possible outcomes can occur in a universe that starts off like ours 13.8 billion years ago increases more quickly than the number of independent universes that come to exist in even an extremely inflating universe. Unless the universe was born infinite in size and infinite amount of time ago, or it was born finite in size and infinite amount of time ago, it's simply not possible to have enough universes to hold all the possible outcomes.
But if the universe was infinite and cosmic inflation occurred, suddenly the multiverse includes an infinite number of independent universes that start with initial conditions identical to ours. In such a case, anything that could occur does occur, but occurs an infinite number of times. There would be an infinite number of copies of you and me and the Earth and the Milky Way, etc., that exists in an infinite number of independent universes, and in some of their reality unfolds identically to how it did here, right up until the moment when one particular measurement takes place. For us in our universe, it turned out one way. For the version of us in a parallel universe, perhaps that outcome exists in an infinite number of independent universes, and in some of them, reality unfolds identically to how it did here, right up until the moment when another particular quantum measurement takes place, and perhaps that outcome is the only difference in all of our cosmic histories.
Is the Mandela Effect all about false memories? Or could we be remembering the real truth? In a quantum mechanical sense, this boils down to two fundamental questions. Is it possible that there are multiple past histories of the universe where different observable macroscopic outcomes have occurred that would lead us to a universe today that has the same quantum state that our universe possesses? And is it possible that a thought, memory, past experience, or even a person's consciousness from one of the other universes could overlap or even swap with this one from the present universe we inhabit? The answer seems to be, it's possible. To achieve a macroscopic difference from the quantum mechanical outcomes means we've already crossed into the classical realm. And that means the past history is already determined to be different. There is no way back to a present where Nelson Mandela dies in 2013 if he already died in prison in the 1980s, unless multiple universes do exist and some type of non-local information transference from universe to universe is possible.
What if quantum entanglement can connect to parallel universes? Quantum entanglement is where two particles become linked and can instantaneously affect each other, even if they're separated by vast distances. As we stated earlier, anytime a quantum process occurs anywhere in the universe, this wave function splits in two, meaning parallel universes are constantly created. As an exploration of quantum theory and the multiverse unfolds, the narrative leads us to a contemplation of the profound implications of these concepts. It prompts us to question the very nature of reality, suggesting that the Mandela Effect might be a manifestation of the intricate interplay between quantum mechanics and parallel universes.
The idea that there could be an infinite number of parallel universes, each with its own set of outcomes and variations, challenges our conventional understanding of the universe. consider the profound implications of eternal inflation and infinite universe born with initial conditions identical to ours, giving rise to a multitude of copies of ourselves, Earth, and the entire cosmos. Is the Mandela Effect a result of false memories, or a glimpse into the complex fabric of reality dictated by quantum entanglement and the existence of parallel universes? The concept of quantum entanglement connecting parallel universes adds another layer of intrigue. The idea that particles can instantaneously influence each other across vast distances, leading to the constant creation of parallel universes, raises fundamental questions about the interconnectedness of the cosmos. If you like what you're seeing here, please like and subscribe to our channel.